So the last topic we're going to cover today, and then we'll wrap up, is stream common aggregate operations. So we talked about creational operations, these factor methods like of and stream and parallel stream and so on. And now we're going to talk about some common aggregate operations. So if you recall, an aggregate operation is used to perform a behavior on elements in a stream. Remember, we talked about higher order functions and all this good stuff. So an aggregate operation would be something like map or filter, and it performs a behavior. And the behavior that's performed is typically implemented by a lambda expression or a method reference that corresponds to a so-called functional interface. And a functional interface is this capability in modern Java where you typically have one abstract method, and then you can use all the modern Java functional features like lambdas and method references to avoid having to make explicit objects in the traditional way of doing things, or having to use an anonymous inner class. Here's a simple example of this. This is the map aggregate operation, and it's applying a behavior, which is the capitalize method, which we'll look at that shortly. And that method is being provided here as a method reference. So the method reference is just kind of shorthand saying, use this method to implement the behavior and capitalize the elements in the stream that begin with lowercase or uppercase h. And you can see here that that is going to convert Horatio with a lowercase h to Horatio with an uppercase h. Some aggregate operations perform behaviors on all the elements in a stream. Other aggregate operations perform behaviors on some elements in a stream, and we'll talk about them. So I like to refer to these operations that do things on everything in a stream as run to completion operations, and I like to refer to the aggregate operations that perform behaviors on some elements in a stream as short-circuiting operations. So run to completion does it for everything, short-circuiting does it for just some. And we'll see the conditions under which some of them are used. You can think of aggregate operations being composed of a pipeline of processing phases. We talked about pipelines before. There's also this analogy if you've ever had a water filtration system where you take the water in from some source that may not have all the impurities taken out by the county or city, and then it goes through those things and removes different kinds of impurities. So what we're doing is we're connecting things together. So the output of one aggregate operation can then be connected as input to the next one in the stream. Java supports this pipelining via fluent interfaces. And this is a programming paradigm. You may have seen this if you've programmed a lot with modern frameworks, Java being one of them, but other languages do this too now. And you can see here where we basically connect up the operations by chaining them together. And that's called the fluent interface pattern. So here you can see we have the of factor method that converts the array into a stream. Then we say dot filter. Filter is an aggregate operation. In this case, it's an intermediate operation that returns a stream that contains only the elements that match the predicate. In other words, in this case, only things that start with upper or lowercase h. Then we do map. That's another intermediate operation that's chained together that will do the capitalization. So it returns a stream of applying the capitalized method or function to every element in the stream. Sorted, and this is a stateless operation or stateless behavior. Sorted is a stateful operation that returns a stream composing of results sorted in ascending natural order. And then finally, we compose that with for each, which performs an action on each and every element in the stream, in this case, to print them out. So that's what we mean when we talk about chaining things together into a pipeline. We use the fluent interface pattern to connect all the different parts. Now, you could program this one local variable at a time, but it would be very awkward and very ugly. So I recommend you get into the habit or learn the programming model of fluent interfaces, because that's what you're going to see all the time with streams. Now, an interesting thing to note here is that the way this works under the hood is this uses something called internal iteration. And we'll talk more about internal iteration later in the course. And that has a couple of benefits. First, it makes it much less error prone to do things versus external iteration. And number two, it allows for transparent optimization, because we can go from this approach to a parallel stream approach without changing anything here at all. Well, you have to change one thing. We have to change that this is running in parallel, but that's very trivial, and it doesn't change the other structural elements of this particular stream, this particular pipeline of methods that are connected together using the fluent interface pattern. In contrast, if we program this the bad old way with Java 7 style features and earlier things like loops and if-else statements and so on, we would end up with something that looked like this. So you can see in this particular case, this uses external iteration with all the older style of things. So this is the same behavior as that, just done in a more cumbersome style. So here we make ourselves a new linked list. Then we go ahead and iterate through every element in the list. We check to see if the element in the first location of each of the list items starts with an uppercase or lowercase h. If it does not, then we remove it from the list. Otherwise, we consistently capitalize it using the loop counter to increment by 1. Then we go ahead and sort the list, and then finally we go ahead and use a Java for each loop to iterate through the list and print each of the items to standard output. So there's a lot more opportunities for accidental complexities here. We can get off by 1 errors. We can forget to increment the loop counter. This code is just ugly and very non-canonical. And it's also much harder to optimize. If we wanted this thing to run in parallel, oh boy, would we have a lot of work on our hands. It would not be something you could trivially do. We'd have to do a lot of extra work on our part to make it more optimized and more scalable. So that's the end of the overview of Java Common Aggregate Operations. Not surprisingly, there's way more about all this stuff that we have not even begun to scratch the surface of here. This is just to give you a high-level view. When you do your first programming assignment, you will get a chance to play around with all these different concepts in the context of Java sequential streams.